Alright, so here we have a random logarithm problem. Given that a square plus b square equal to 14ab, let me try to write it out here. So a square plus b square equal to 14ab. Show that log a plus b over 4 is equal to half ln a plus ln b. Okay, so notice you want in the bracket a plus b. So it means therefore that we need to rewrite this as a square, as a perfect square. For this to be a perfect square, then we can add 2ab to both sides. So let's add 2ab to both sides. So add 2ab to the left hand side, and we add 2ab to the right hand side. So here, the left hand side, that's the perfect square, a plus b all square, and on the right hand side, this is 16ab. Good? And where do we go from there now? Notice in the bracket is just a and b, so we don't want this to have in the coefficient. So we can divide both sides by 16. Divide both sides by 16, so 16 to 16, right? So here we have AB, and over here we have A plus B square over 16. And of course we can take the square root of both sides, so we can square root both sides. Or if you want to say raise both sides to the power of half, same thing as taking the square root. So if we take the square root of the left hand side, what we'll end up with, square root of the numerator is just a plus b. The square root of the denominator is 4. And then we take the square root of the right hand side, which is same thing as raising it to the power of a half. Alright, that's a notation for square root. And then we can log both sides, ln, both sides. So we take the log of this side, so it's ln a plus b over 4, which is what the proof says, ln a plus b over 4. And then we log the right hand side, so we have ln ab to the power of a half. Now let's try and make the left hand side look like the right hand side look like what we have over here for the proof. So coming down here, so this is ln, so we don't need to trouble this, it's already how we want it for the proof, a plus b over 4, ln a plus b over 4. The right hand side now, note we can power, the third rule we looked at, the power here we can bring it at the front, so it's half ln ab, right? Half ln ab. I'll just rewrite that better. Right, so it's half ln ab. And I'll bracket that. But remember what let's come down here. Remember this first rule we looked at. Alright? The first rule we looked at. ln ab is in the consolidated form, so we can break it up. And since it's the product AB, A times B, we can consolidate, we can break it up as ln A plus ln B. Notice if you should consolidate again, you will get ln AB. So ln AB can be written as ln A plus ln B. And that's the proof. That's the proof. So that's quite easily done. Let's look at another problem. So given that a cubed plus b cubed plus 3a squared b equal to 5ab squared, show that. Now we have all that on the right hand side there. Now how do we show that? Of course, same idea as the example we just looked at. So the idea is to rewrite this as a, notice it's cube. So we need to make it a perfect cube. So let me just write out where we begin. A cube plus B cube plus 3A squared B. And to make this a perfect square, a perfect cube, we add 3AB squared. Which means we have to do the same thing to the right hand side. We add 3AB squared. What this is, should recognize A plus B all cube. And then this would be what? 8. Those are like terms, right? 8AB squared. So, what can we do now? So we can log both sides. So log the left hand side and log the right hand side. So log both sides, right? Now the left hand side, this power, we can always move it to the front here. So it's 3 log A plus B so next we can, to get A plus B, transpose of A plus B, we can take the cube root of both sides. I will raise both sides to the power of 1/3. So I raise A plus B cube to the power of 1/3. I would say we take the cube root and we raise 8AB squared to the power of 1/3. So raise this to the power of 1/3. 1/3 times 3, that's 1. So we just have A plus B here. Raise each of these terms to the power of 1/3. So A to the power of 1/3, that's 2. Or the cube root of 8, that's 2. And then we are left with AB squared. And all of that to the power of 1/3. Now we can divide both sides by 2. So we end up with A plus B over 2. And 2 into 2, 1. And we have AB squared AB squared all to the power of 1/3. And then we can log both sides. So take the log of this side. And then we take the log of this side. Just separate here. So we end up with what we have on the left hand side for the proof. Well, not quite yet. So we'll have ln A plus B over 2. And remember with logarithm, this power here we can bring it at the front. So this is 1/3 ln, and then in the bracket we have AB squared. Now we can times both sides by 3 because we want this to have there. So we're using log, not ln, right? Just to use the same log that's in the proof. Alright, so log, log. Alright, so the base, we just assume the base is 10. So we multiply both sides by 3. So 3 times left hand side, we get 3 log A plus B over 2. And 3 times the right hand side, so 3 times 1/3 give us 1. So all we have is log AB squared. So the left hand side is okay, same as what's in the proof, what we're asked to prove. So that's left hand side is fine. Let's see if we can rewrite the right hand side. So the right hand side, remember the rule, the first rule, it's a product, so we can separate it by addition. So this is log A plus log b square. And of course, log b square can be written where you put the power here at the front 2. So here we have 3 log a plus b over 2. And then we have log a. And we can rewrite log b square. I think it's the third rule that we look at as 2 log b. And that's the proof. That's the proof. Alright? That's what we're asked to prove. Good. That's the proof we're asked to do. And that's it.